Assalamualaikum and hi everyone. I'm Mohd Fahmi bin Abdul Kadir, metric number SX153095KAWF04. Today, I will present a final year project, effectiveness of active leakage control programs against non-revenue water. Presentation outline, introduction, problem statement, aims and objective of study, scope of study, methodology, result, conclusion and recommendation. Introduction. Non-revenue water NRW is defined as the difference between the volume of the produced by a water treatment plant and the amount of volume derived from bill reached each month. Water supply issues are a major issue in the water supply sector to Malaysian consumers. In 2010, the average NRW rate in Malaysia was around 37%. The various causes of water loss are due to real loss, which is the loss of water from broken pipes, leaking pipes, overflow tanks, and other physical losses. I give you some example. A water treatment plant produces 1 million liters a month. Through the bill collected by the water company, only 600,000 liters of water were recorded. The remaining 400,000 liters are considered NRW. The NRW percentage is 40%. Problem statement. Non-revenue water NRW rates are a major challenge for the water supply industry without a good and efficient plan. On average, the NRW rate in all states in Malaysia was 37% and registered a 1% decrease to 35.6% in 2014. This indicates that the percentage of losses due to NRW is still borne by many water providers in Malaysia. Proactive measures need to be carried out holistically and effectively to ensure that the non-revenue water rates are controlled and reduced in the short run. Now let's look at the percentage of NRW by the state in Malaysia in 2013 and 2014. The table shows that Perlis recorded the highest NRW in 2013 at 62.4% and 55.8% in 2014, while the lowest NRW was Pulau Pinang 18.2% in 2013 and 18.3% in 2014. Aims and objective of study. The objective of study are to identify the criteria involved in the selection of location implementation of an active leakage control programs, to analyze non-revenue water based on the strategy of implementing an active leakage control programs. Scope of study. The purpose of study was to identify the effect of active leakage control program conducted under the supervision of Pengurusan Air Selangor Sembahat Air Selangor Hulu Langat Region at District Metering Zone DMZ HL014 Taman Rakan, HL268 BBB Section 10 and HL017 Sungai Kantan. To meet the objective, the study will cover the following areas: collect data on leakage rate at the study site, use the search and repair method in implementation of the active leakage control programs, analyze the result of the active leakage control program against the non-revenue water. Methodology, step test. Normally, the flow of water into the district metering zone, DMZ, will be recorded on the flow meter and the flow rate will be low each time the shutdown of the step test valve or step isolation is made for the contaminated area within the DMZ. Data capture tools such as loggers on the flow meter or manual readings will be made on the DMZ flow meter to record the flow rate at the close of the step test valve. Each valve closure will usually be done periodically, where the closing between each step test area will be extended for 60 minutes. The net leakage rate estimate for a DMZ will be calculated using the formula net flow equal to minimum net flow MNF deduct legitimate night flow, LNF. For example, this table is a result of the step test for the HL014 Tamarakan. The flow meter recorded a reading 6.377 liter per second after the inline Swiss valve SV2 was closed. This indicates that there may have been a burst pipe incident in the area due to a water flow reading of 33.252 liter per second. Therefore, the exact method is used to determine the exact location of the broken pipe. Pinpoint method. A detailed methodology for leak detection involves visual method using sounding stick and subsequently using leakage sound loggers, correlator, and ground microphone. Most cases of leakage can be seen directly through sight, sound, and smell, while the sounding stick can also be used during visual inspection. However, if visible leaks cannot be found visibly, despite the fact that there is a leak hidden in the pipe, a detailed investigation should be made between the part of the pipes. Another method used is to use a leak noise correlator that connects sound signal from one point to another to determine the exact location of the leak. This practice is usually used between 2 a.m. and 4 a.m. because the minimal water usage at that time. This is a detailed result of location, types of leakage, and instrument used at the study. Site 1 HL014 Tamarakan. The types of leak found were pipe burst at Jalan Rakan 22 and ferrule leaks at number 77 Jalan Rakan 15. The use of instrument is very important in locating the actual incident of the pipe burst. In this situation, a leak noise correlator and listening stick are used. This is an example for pipe leak detection works that use instruments such as listening stick, leak noise correlator, and noise logger deployment. Result. According to the first objective, the location selection criteria of the leakage control program is an important basis for determining the correct level of location selection requirement in ensuring that it can have a positive impact. This is graph that show the minimum net flow recorded the highest decision by 38% compared to others to meet the selection of active leakage control program criteria. Minimum net flow is a very important medium for analyzing leakage rate in an area. Let's look at the minimum net flow differences before and after the implementation of the active leakage control program. For study site 1, HL014 Tamarakan, the saving rate was 37.889 liter per second. While study site 2, HL268 BBB section 10 gained saving of 17.211 liter per second, and study site 3 HL 017 Sungai Kantan recorded close to 2 liter per second. This gives a good return to water supply companies to reduce the non-revenue water rate. On overall, the NRW will be calculated using the following formula. Water treat production reduct water consumption equal to non-revenue water, NRW. All of these values were calculated using total daily flow, TDF, through net-based software, while table 1 shows the percentage of non-revenue water for before and after the strategy of implementing active leakage control program for all 3 study sites. Based on figure 5 shows the percentage of non-revenue water and NRW before and after the implementation of the active leakage control program at all three study sites. SX153095KAWF04 Tamaraka recorded a 45.35% decrease, while a 34.3% decrease in NRW percentage in HL268 BBB section 10 and 6.3% decrease in HL017 Sungai Kelantan. Given the significant decline in the three study sites, the water supply companies will have good returns and positive impact. Conclusion. The selection criteria used in determining the location of active leakage control program reviews is based on minimum net flow, frequency of broken pipe cases, type of pipe, consumer complaint. Therefore, it is clear that active leakage control program strategies can control and reduce non-revenue water levels. Water supply companies need to ensure that treated wastewater is minimized to meet increasing consumer demand each year. Among the factors of an active leakage control program are not able to achieve optimal result when performed by less skilled workers. Systematic analysis and monitoring less in place during the program. In addition, this may be due to the natural increase rate (NRR) and the manner in which it is performed does not fit the condition. Recommendation: the pipeline replacement program is one of the alternatives to controlling the lowering NRW rate. Despite replacement program should be focused on asbestos cement. Pressure management can be done using pressure reducing valve (PRV) and pressure control technology based on flow rate or critical pressure location. This alternative to stress management is more economical compared to pipe replacement. Besides, the water utility company should be recommend using the timer system at night as it operates between 2 AM and 4 AM to control water pressure in the high district metering zone with high minimum night flow MNF. That's all from me. Thank you. Assalamualaikum.